welcome. Thank you for coming. I understand that you have many choices and you could be somewhere else right now, so I appreciate that you came to listen to me. Shoot, wrong button. So, my name is Petra Cross. I'm actually from Slovakia. I'm from Žilina. My maiden name is Popluharova, so you can imagine how easier it got for people to spell my name after I got married. I'm a software engineer at Google. Here's a few more facts about me. You can read through it. I've been at Google for 6.5 years. I spent 3.5 years at the search team, working on evaluation of search results, and I'm on Gmail since 2008, so it's been 3 years since I took Gmail. I have a cute little puppy, and I like to photograph people. So I came here to talk about software development at Google, and it seems like this slide doesn't belong here. Why is it so red? Is it red or is it just me? It's not red here. Anyways, so this slide doesn't seem to belong to this presentation, but I believe it's important to bring it up because this is what Google is trying to do. This is the mission statement that every Googler knows by heart. You can wake me up at 4 a.m. and I'll tell you this from the top of my head. And what I'm going to talk about is just one of the things we do to achieve this objective, this main goal. So everything that Google does is trying to achieve this single goal. Now that you learned what Google is trying to do, I'm going to talk to you about what this talk is going to be about. So, real briefly, I'm going to talk about teams, the different teams that we have at Google, how they're structured, the kind of roles that we have on the teams, what kind of titles people have, where do they sit, how do they interact. Then I'm going to briefly talk about the development methodologies in the software industry in general. I'll just list 3, don't worry about it, there won't be too much about it. Then I'm going to dive into talking about what we do specifically at Google. I can't really tell you what other companies do, because I only worked at one other company before Google, and they haven't been doing what we're doing. But I will just be talking about how Google applies agile software methodology to their software development. So let's talk about teams and roles first. This is the busiest slide here, okay? The rest of the slideshow will be a lot easier, so bear with me. This is the most complicated slide. Let's just go one at a time. Here is part of the software engineering ladder. There's many different ladders. There's marketing and sales ladder and other ladders at Google, but I come from an engineering ladder, so I can talk to you about the different titles and roles we have in engineering. Obviously, we have vice presidents and CEOs, but from the point where it gets interesting for me as a software engineer, I'm directly involved with these types of people. I'm involved with engineering director. This person is a manager of my manager, and he is or she is responsible for translating the business needs to technical requirements. So you would have one engineering director for all apps, for example. Or if the product is so big, you might have one engineering director for Gmail and a different engineering director for calendar. This person usually is responsible for a few hundred people. Then you're probably familiar with product manager. Are you familiar with that? These people are former engineers, but they kind of grew into this role of product management. So these people are closest to our customers. They know what customers need, or they think they know what customers need. And they translate their product vision into specific product requirements that engineers need to implement. I'm mostly dealing with engineering management and down. Engineering manager is, again, a former software engineer who is now purely managing engineer. This person doesn't code anymore. They are responsible for multiple projects. So for example, in Gmail we have engineering manager that is responsible for five different teams. Each team is working on one project. And the reporting structure is extremely flat, so most developers, most software engineers report to this person. Then the next role is software engineer / tech lead. I'm here. This is where I am right now. It's basically a software engineer, which I'm going to get to, plus a person who advises other engineer on the team. This person prioritizes features with the project manager, goes to a lot more meetings than the rest of the engineers, and you're just there to help others and to make sure that they are not being distracted from coding. So I code a lot myself as well, but if there is a meeting with other team, we need to define an API between my team and their team. I'm the one who meets with them. Or when there is an information that comes down from engineering director, my manager meets with his tech leads and communicates it to tech leads. And then tech leads will then make sure that the software engineers and the tech lead themselves implement what needs to be implemented. Software engineer you're all familiar with, right? It's a person who designs systems and implements them. SCT, not every company has SCTs, but SCT is a type of engineer that writes testing frameworks. So, for example, a framework that would behave like a user in the Gmail UI and click on different things and make sure that the UI behaves correctly. And then the TE, the test engineer, is actually the person who uses this testing framework to create these tests. Right, this is the end of the long slide. Here's an example of the reporting structure. You have vice president, engineering director, manager, and then you would have 10 or 30 people here. It's completely flat, except sometimes some software engineers have interns for 3 months or so. Some of the engineers become tech leads, and sometimes the tech lead can become also a manager. So you would have a couple of engineers working with the TLM. Do you have any questions so far? Do you actually understand everything I said? Okay, good. Am I speaking too fast? No. This didn't get rendered well when I converted it to PDF, but it's supposed to be centered. This is an example. If you see the previous slide, this would be a team at Google. It's everything that is every person that works with this tech lead. For example, up to here would be one team, and then this would be another team. In every team, you have to have one tech lead, one and only tech lead. This is the environment that people sit at. So when you join, you get 24-inch monitors, or you can get one 30-inch monitor. You get, you know, the ergonomic setup and everything. You can pick a standing workstation, like Greg here. This is our old building. We called it a dungeon because it was really dark. We are in a much better building now.
I'm sorry, where is it?
This is in Mountain View, part of Googleplex, California.
California.
You said you can have 24-inch.
You get two 24-inch or 30 or one 30-inch, but some people get more. You know, when you see them laying around, you just take them if no one's complaining. So the point of this slide is to show you that the space is open. Anyone can hear anyone. There are some offices around the perimeter. It's because the building already had offices, not because we built them. We put them there, and you have 3 or 4 people in each office. We want to be able to collaborate with people, and if you don't want to be disturbed, you would put headphones. Is it a headphone? No, that's something else. You would put headphones on and listen to music if you don't want to be disturbed.
There are usually so many. The people here are pretty dense. The density of people.
So this was, you mean density?
Mm-hmm.
Yeah. So Google keeps growing.
Yeah, so it's
kind
not
of exponentially.
It's not intentionally.
No, this is not intentional. We keep moving every few months. I've moved, actually it's been pretty good. I haven't moved for the last year, but I moved 6 times already for the last 6.5 years. Every time the team grows, we just move to a larger space, and then there's more
So
space.
if you start occupying team space, the closest roommate is
The closest roommate will be like you are for me right now. Or right across my desk will be another desk. And these are actually 4 desks that are like štvorlistok. How do you say that in English? I don't even know.
Clover?
Clover flower, clover leaf. So you might have a team that is in one štvorlistok and another team at another.
What's the max size for one team?
We want to have each team should be the size of a family, so you can literally discuss things without having to go to different offices. This is Fluffy. She's chilling on the beanbag. This is our new space. This is where Gmail is right now. I happen to have an office, which is pretty unusual, but I deserve it because I'm always cold and offices are much warmer than the open space. And just a thing to point out, the balloons are at the desks of people who are new engineers, people who just got hired. So there's balloons popping up every now and then. This thing in the back is a dashboard that shows continuous build. So the green means that the code is compiling, the red means that the code is not compiling. So there's multiple different sets of targets that continuously kept built and all the tests get executed. And those that are red, it just means that someone needs to go in and fix it, that someone broke the build. Okay, so what are we doing in this space? I have a prize for you if you answer this question, because I showed you where we sit, and now I want to know, what's the point? Why are we even there? What are we trying to do? And I have, what do you call it? Flyer? What do you call this? Frisbee.
Oh.
So, any takers? Any answers?
Make the world a better place.
We are organizing the world's information and making it universally accessible and useful.
In other words.
Yes, making a world a better place. Can I throw it at you?
Oh,
This is a sleeper.
thank you.
All right. So, here's the answer. Now another prize. How are we doing it? What do you want? What kind of prize do you want? Another frisbee? Or sticker? Sticker? A long Android sticker? How are we doing that? How do you make a world a better place if you're a software company? Come on.
Working together.
At least there's an effort, so yes. By creating the best possible software while making a lot of money. There you go. So now I'm going into the nitty-gritty details. This is how every company, I think, software company functions. You start with the ideas, right? With some goals. Someone converts these to features. So usually these are the PMs, the project managers, who define features that need to be created, and they request the features. Then someone, either PM or someone else, prioritizes these features in a certain order, and they are planned. They are actually going to be developed at some time, at some point. Then people are working on them, developing. They are testing while they're developing. Many companies don't do that. I know that, I'm not going to mention which companies, but lots of companies don't test while developing. They actually do it after the code is checked into a code repository. At Google, every software engineer writes their own unit tests. We use JUnit for Java and Python tests, and I don't know, all kinds of Python libraries for that.
In which language do you program?
I program in Java and Python and sometimes scripting, and then we have a number of different Python-based internal languages for mostly configuration languages for making sure that you can set up your that your code runs in production. You need to learn a little language to do that. So once it's tested by a developer, it goes into code review. Again, not every company does code reviews. The code is reviewed by another pair of eyes. Hopefully pair of eyes, not just one eye. But it needs to be reviewed by at least another software engineer, because we don't want people to check in some malicious code. And it also allows you to learn from other people. I get lots of useful comments during code reviews, especially if I send it to people who are not on my team, because they have completely different perspective. Once it's in code review, then you use Git. We use Perforce, but we have a Git 5 wrapper for it, and then, or SVN, or any kind of repository system to check the code. into the repository. And at some point, someone starts to build a binary that they push to production servers, a small number of them. People test them. We have testers in Hyderabad, in India. And then it goes to canary, which means that it goes to a larger number of machines that, I don't know, 1% of traffic goes to, or 5% of all users use. And once that's stable for a day or two, then they push it live to production, 100%. So this is a regular flow. You're probably all familiar with it, or it's pretty intuitive just by looking at it, right? What we're trying to do...
Small question.
Uh-huh.
You said that basically the bridge between the idea and the feature,
Mm-hmm.
that it's about project manager.
Mhm.
The project manager translates these kind of business ideas into
Mhm.
features. Does it mean that the project management role is kind of a heavily contentious? The guy needs to know the product, and
Yeah.
his job is not only basically allocating people and
No,
filling out.
Product
roles.
manager does not allocate people. The engineering manager does that. So my manager would decide who works on what team. And every now and then we have different goals, so the teams break up, and then he creates different teams from the same amount of people. The
And everybody
project
else in the
manager
chain
only
is
is-
actually shielded from the business requirements.
Yeah.
The technical guys deal really only with the features.
yeah, I rarely deal with project managers.
Thanks.
Actually, technically it's deal with product managers, but regular developers shouldn't, because they should just be able to focus on individual tasks they work on.
So who breaks down situational tasks?
We are gonna get there just in a few slides. All right, this is our goal. We want to do the same thing, but in a lot shorter time. Few things that come to your mind, like how you can do it, right? You can just develop faster, or you can just develop what really needs to be done. So you need to focus the efforts. And from the business perspective, Google wants to maximize return on investment on developer time, right? Obviously. So from our perspective, we can do it by adding more people or reducing the waste. So what do you think we do? Adding more people? No.
No.
The tails away.
Yes, we reduce the waste. And the frisbee goes to you. Can I throw it? Cover your head. Woo! Here's the sleeve. Thank you. So it turns out when you add more people, when you add twice as many people, you don't get it down twice as fast. It may actually take longer. So reduce the waste. Where are we? Okay. And here is what we don't want. We don't want to waste money, just like many companies in America do. I have a little translation here. So it's 60 to 70 milliards of Czech crowns, not crowns, US dollars are wasted every year alone. And it doesn't even, this does not include projects that are delivered late, or that are, I don't remember, there's two types of things that doesn't include. Yeah, over the budget, yeah, those that are over the budget. So here's a little example. I don't want to ask you to read this, but here in state of California, in 1994, Department of Motor Vehicles wasted $44 million on a software system that was never launched, or maybe it was, but it was buggy, so they never used it. So we don't want this. So how do companies develop? Hmm?
Exactly what Google does. Google makes many little things, many little services, and try if they can.
Yeah, but they don't staff them with hundreds of people. They put a 5% team on a little project, and when they release a demo that looks good, then they add more people. They don't just, well, there's a few examples obviously in every company, but we're not trying to do that.
So Google Buy was a little project.
Yeah, it was
for
not-
a few people.
That might be one of the examples, yeah. So I'm going to talk, for the rest of the talk here, I'm going to talk about specific methodology that we do, that we use to develop software. I'm going to first describe what are the three main, most common ones. The first one is called the waterfall methodology. And it's coming from a manufacturing industry where you actually create a tangible product, a physical product, that, like a car or an airplane or a building, so you don't really have a chance to go back and fix it, or at least you can't completely redesign it. So they would define the requirements up front, and then there's no way to change them once it goes into design implementation, verification, and maintenance. So obviously this is not very efficient. We don't do that. So this was adjusted to software by making this into the spiral model. And the spiral model is, you can imagine it as multiple waterfall models in a row, in a cycle. So you would do waterfall until you create the first prototype. Then the customer sees it, gives you feedback. Then you do another waterfall until you get a second prototype. And each iteration would be 6 or more months. Again, not very efficient. And the customer only sees it once at the end of when the prototype is done. The one I'm going to talk about for the rest of the presentation is the agile model. How many of you heard of agile? Did you lift your hand if you heard good things about it? Okay, lift your hand if you heard bad things about it. 50-50. So I'm going to try to convince you that it's actually good if it's done right. Because there's lots of different ways to do it, and if you ask people in many companies if they do that, they would say they are doing it, but they actually aren't. They think they are doing it because they are on iterations, but they're not really doing agile. So the main points of agile are that you are constantly collaborating with your customers. You always get feedback from your customers. Do you see the slides from there? Yeah. Okay. So you don't define the requirements up front. They can be changing on you every single day. And that makes you very flexible if you can do this. Then obviously you have to iterate a lot faster, not every 6 months, but every 1 or 2 weeks. And because every 2 weeks you were done with coding something, you can release it more often, so you have frequent releases that customers can see more frequently. The teams are self-organized. Now this sounds really scary, right? If you tell people to self-organize, but there are some rules to it, which I'm going to get to later. And what you've seen in the slides, a few slides back, the open space encourages collaboration. That's where the agile teams live. So let's get into this. There's 3 major or most common flavors of agiles. You probably heard about 1 or 2 of them. You heard about extreme programming, right? That's mostly known for pair programming. They call it promiscuous pairing because you are programming with a different person every day. So you need to be pairing promiscuously, which allows you to learn from more people than just one person. Then you have Scrum, which is not really for engineers, it's more for the project managers that manage agile teams. And then you have Kanban, and that's an interesting one. Is there anyone who speaks Japanese?
Yeah.
No, you don't look very Japanese, but I was like, my last hope. You do?
Yeah.
Can you translate the word Kanban?
It's like a sign.
Sign, a board, right? So I was told it's a whiteboard. Do you call whiteboard a Kanban?
No.
Okay. I almost told you a lie. If he wasn't here, I would be telling you that it's a whiteboard. Okay, Kanban is, at least in the world of agile, here's an example actually. A Toyota company is using these boards, these cards, that travel along every single part. So in the logistics system, as the part is being manufactured and installed into an actual car, it keeps this thing with it. It contains, I don't know what all these things mean, but it's supposed to tell you what state it's now, what state it's in now, and what's the next state. So at any point in the system, when you just take the card, you know what to do with this part, where it's supposed to go, what time it's supposed to be there, and so on. So there's an analogy in Agile, you work with cards, whether they're real paper cards or just an item in some software. And I'm going to get to this later. So now that I talked to you about what are the different software development methodologies, what do you think Google does? Which one do we use? Do we use waterfall?
No.
No? Do we use, what is it?
Spiral.
Spiral?
Yes.
No.
We do? So we would change requirements every 6 months?
You're using the agile.
Yes, we do agile. And what do you think we use within agile? Extreme programming, Kanban, or Scrum?
Combination of them.
Mm-hmm. Who said the combination? This deserves a prize. What do you want? We have t-shirts. Want a t-shirt? Or a pen?
Or a sticker will be better.
Sticker? Android sticker?
Doesn't matter.
We also have these chrome pins. And we have tattoos.
Oh.
Do you want Google sticker or Android sticker?
Google sticker.
Okay. They're all the same, okay, so you don't have a choice. Thank you. So yes, we do, that's the beauty of Agile. You can do anything you want, and you just pick and choose from any methodology that you want. Whatever works best for you. There's no team, no two teams that will be doing the same thing. Everyone does it differently. So I'm going to mostly talk to you about what Gmail does. And on Gmail we have multiple teams, and they all do it slightly differently. So I'm going to talk to you what my team does. Doesn't mean you're supposed to do that, okay? You only listen to what works for us, and then you then decide what would work for you. Yes, mostly plain Agile. So if you go to this thing called Google, have you heard about it? It's this thing that finds stuff for you. Google.com, have you heard about it?
No.
Okay. If you type 2 words there, if you type 10 things, the first search result would be a list of 10 things that Google found to be true. And the number 1 thing on the list is that if you focus on the user, everything else will follow. And we actually do that even in our individual day-to-day software development. So when we receive a request from a PM, it comes in as a user story, as what the user wants. And here's an example that's not even from Google, but I just want to be generic here so it's clear. A story would be an ATM user wants to see a balance, right? There's always who wants to do what. A manager wants to view the usage in all bankomats, ATMs, bankomats in San Francisco. So that would be a user story. You give this to a regular engineer and it will be overwhelming, right? Because there's many ways to do this, and that's where the planning comes in. At some point, engineers take a story, if the story is prioritized by the PM, and it means we have to do it, and decide how to do it. And then we break it into multiple tasks. Sometimes the stories are so tiny that you can do it in 1 task. But usually it would be 1 to 5 tasks, somewhere in that range. And just, as you notice, both story and the task are clear. There is an acceptance test, so it needs to be clear from this description when the job is done. So it's really easy to say, oh, this was done, and check it off. Task is doable in in few hours or a couple of days. If it takes you a week, it's not a task. You need to break it down into multiple tasks. Because people are a lot better at estimating small tasks than telling you how long the whole thing is going to take. Alright? And we're going to talk about this later. The task will have a description, just like a story has a description. It will have a size, an owner, eventually, if someone starts actually working on it, they're the owner, and a state, just like the Kanban cards, the Toyota cards. They are going through multiple states to actually get to the end, to customer. So, where are we now? Here's an example for those who like to learn by example. In our example user story, where a user wants to view her balance, what would an engineer do, right? You all engineers? Are you guys studying engineering? Who is? Okay. So, I'm gonna explain it then. So, and if I'm being too, if I'm talking too much about it, I apologize to the engineers who already understand what I'm talking about. Okay. So API is an interface, application programming interface. It's like an understanding between bankomat, ATM, and the server. It's like a protocol they follow to communicate. When a server receives a request from ATM, it needs to come in a certain format, right? It just can't be just anything, because you might have hackers trying to contact these servers. So there must be obviously authentication and other things involved. But imagine that this API will be something like, I'll send you my authentication credentials, and I'll give you the ATM user number, and you will return me an integer that will be, well, not integer, will float, because the person can have multiple cents, not just full dollars. You will return me some kind of number that will be the balance. So you define this kind of API, and make sure that whoever owns the server in the bank will agree with that API and is willing to send you the data in the format that you ask for. So once you do this, then you actually implement the code on the server side. Whoever manages the database will help out, or you can do it all by yourself if you have access to everything. And make sure that the servers that the bank runs will be able to get the user ID and look it up in the database and then return it. And then the third thing will be a UX designer, user interface designer, and some kind of front-end engineer would create this beautiful page in the actual ATM in Bankomat that would allow you to click on a button, and when you click on a button, that thing will call this API that will talk to the server in the backend and return it. So there will be 3 tasks. But obviously for this kind of thing, it will be a lot more tasks. There will be a lot more tasks, but I just wanted to simplify it for you. Is it a good example, or should I do differently in the next lecture? Is it a good example? Yes? No? You guys are
Yes.
For everybody who hasn't worked in a bank, it's a good example.
Well, I have never worked in a bank, but I know what everyone uses Bankomat ATM, right? Okay, so as I was talking about the states of the tasks, so how they go and how the state changes on the Kanban card, you might have every task starts in an icebox, and there'll be multiple states it goes through. So you put it on a list or somewhere in a spreadsheet. Anything that people ask for, anything, even if you don't want to do it, you put it there and you say, sure, we'll prioritize it. You don't want to say no to people, right? You always kind of agree to work on everything, and then you prioritize. It's called icebox because it's just sitting there, chilled, it's chilling. No one's working on it yet. It's not prioritized. It's just a pile of requests that are sitting in the icebox. And you get features there, the user stories, and you can also have the tasks there in either form. It's in the icebox. Once product manager actually decides what we're going to work on, they have another list that's prioritized, and it's the backlog. It's like, it's a work list. It's the stuff that people are actively working from. They're taking from the top and picking tasks from the top each time they have a time to pick up a new task. It's extremely important that backlog is sorted by priority. I'm going to get into this in the next slide, yeah. And the PM or tech lead, because not every single team has a PM. My team doesn't have a PM. I'm a tech lead. So I prioritize the stories or the tasks in the backlog. And if there's something super urgent, my manager would say, hey, bump it up. We want to get this done next week. There was a question.
If you're using some kind of project management software, and if it's your own or if it's some project like Basecamp or something like that.
So I'm not a product manager. I don't use product management software.
But you can know something about it.
For this,
Yeah. For tasks.
we happen to be using Pivotal Tracker, but it's not like there's many different choices that many different software options you can use. I'm going to show you in the next slide that teams that are all in one office, they're actually using real whiteboard, physical whiteboard, and paper tasks. My team cannot do this because one of my coworkers is in Seattle, and he wouldn't be able to see the whiteboard. So these are, can you see the difference between these? It's like whatever, anything that people want, and this is, we're going to work on this, and in this order. And now for those who are visual like me, do you see the difference between icebox and backlog? This is a river. This looks really bad, the colors. A river with a pile of floating tree trunks. And you have logs here nicely ordered. This is backlog, that's icebox. Now, once you pick the task from the backlog, an engineer always picks tasks from top of the backlog, they start working on it. The task is changed, its status to working on, it's pending or current. So it just means that someone's actually working on it right now, and it will be done in a week or two, depending how long your iteration is. And once you're done, you put it in another bucket called done, and then you kind of stop worrying about it. When I say done, it means that you wrote unit tests, they pass, you code reviewed it, you got approval from the code reviewer, and you checked it into the code repository system. So here's the example I was talking about. Wow, this is so like dark. Can I make this lighter? No. Can you see this? It's actually white in real life. We call this swim lanes because it looks like swim lanes. So I'm going to be describing every single part here because it's hard to tell. This swim lane, it's a scheduled backlog. This is backlog. It doesn't have icebox. Icebox is only like a spreadsheet somewhere. Project manager would be keeping the spreadsheet. Once the project manager or tech lead wants people to start working on stuff, he or she puts it here in this order. So this will get done first, then this, then this, then this, and this will be the last. People that are working on stuff, they put the tasks here in working on. The pending task or current, there's many names for this. Every team calls it differently. But it just means that people are working on it. And this stuff, those are faces, pictures. There's a bunch of pictures here on top. Everyone has like 5 pictures of themselves. And when you work on something, you take it from here, put it there, and put your face next to it so that they know who's working on it. So this is being worked on. 5 tasks. Okay, seems about right. 5 people on the team. Now these guys are creative. They created another bucket called in review. You don't see this, but not every team has this in review. They should be all in one, working on. And then this is checked in, which means done. And again, these guys are creative. They also have additional stuff, like it's in QA and maybe it's being pushed. Some of these are optional. If your team wants it, you can create another bucket for the state, for additional state for your tasks. So this is
there are many tasks in review.
Yeah, that's one of the problems that people. It's always hard to get code reviews for many people because you want to work on your own code, and especially if you're more senior, the junior people are sending code reviews to you because you would give the most valuable feedback. And so you are swamped with code reviews, and some people just decide, I'll do code reviews only at the end of the day so that I can actually work during the day. Some people only write code reviews because they want to unblock people from being stuck on them. So these people, I guess, they like to write code instead of doing code reviews.
You can choose who will do your code review. Or
yeah, so it makes sense to send it to someone who knows the code. If you are the one who knows most about this code, you just send it to any coworker in your team. And they just make sure you don't have typos. They will be caught by compiler, but they just make sure that it's refactored and it's factored the right way. The unit tests are actually testing the functionality that they need to test.
So I can, if I know the people, I can send it to someone who will let it pass more easily.
No, you can't have just people who will just approve it right away. It's your responsibility. So 2 people are responsible for this. If this breaks in production, if Gmail goes down for 2 hours and it goes back to you giving LG after looking at it for 10 seconds, you're in trouble, right? You want to review stuff carefully because it's like 2 people are responsible for it, both the code reviewer and the author. And also, you don't want people to just write some junky code and then you have to keep maintaining it. This is also a way to make sure that no one will degrade the state of the code base.
So can you simultaneously work on multiple tasks?
So the question was, are you guys gonna post this video somewhere? Who's filming this? Because should I be repeating the question? I'm familiar with this. People who watch videos, they never hear the questions. Should I be repeating the questions? Mám zopakovat otázku? Okay, otázka byla. Okay, this is what software engineers are. People who don't like to remember stuff, they become software engineers.
I'm also software engineer. I don't remember.
There you go. So you understand.
I was asking whether people can work on multiple tasks simultaneously.
Okay, the question was whether people can work on multiple tasks simultaneously. Yes, but as few as possible, because the more tasks you work on, the fewer get done. Obviously, if you're blocked on code review, then you start another task. Or if there's something that needs to run for 3 hours, then you start another task. Alright, moving on. This is just a summary of the previous slide. These were the swim lanes that they had. This was actually not my whiteboard, it was another team's whiteboard. I just took a picture of it. But in my team, we have different swim lanes. We have scheduled, we have working on, and we have done. We just have 3. And we have icebox. But we use the software for it, so when you have whiteboard, you can be more creative. Okay, time to give out some prizes. Who remembers what I was talking about in the last 2 slides? And wear size M. You already have a shirt.
I have a question. Can I ask? No.
Are you sure?
I'm not answering.
Go ahead.
Is the one having access to it?
Yeah.
Or
It's
like
there
one
in the
com-
space,
Okay.
in the open space, and that's the good thing about it. It's actually transparent. I mean, not the whiteboard itself, but it allows for transparency. So when there's no such thing as status meetings, when the manager would come and say, "What are they working on? What are they working on?" You'll just point at the whiteboard, like, "Look where my picture is," right? And it saves so much time on meetings. You don't need to spend every day to give any kind of status update to anyone. What was the question? What were the types of states? You have to answer the question. If your hand is up.
Yeah. We
Okay.
were talking about task management and swim lanes, whiteboards.
Yeah. So what were the states? You start in icebox, then you go to
Something
prioritized backlog,
Working on done.
then working on, then done. What size are you? Oh, you are perfect. Sorry. He had a better answer. He had to get the shirt. Okay. Another question, and perhaps another shirt. How much time do we have left? 1 hour left? I was supposed to be done by 7.
So
9 minutes.
Not 6.
50 minutes left. Then, sorry.
50 minutes left? You're saying it's 6:10?
No.
Yeah,
7.
Yeah.
It's already 7?
Yep.
Yes.
You have like 10 minutes or so. if you
Wow, I
want
have to
add
go
up.
fast now. Okay. I'm actually meeting someone at 7:15. I thought it's 1 hour. I hope they find me. The invite guys, who knows them? Can you IM them and tell them where I am so they don't, because they said they're going to wait for me outside. Give their phone number. You?
Yeah.
Yes, he's going to take care of it. Thank you. So when do we actually put the task on the whiteboard? At these meetings. So this is the worst case scenario. These are status meetings, which most teams don't do, but some teams do, and I just put it there. This would be a regular schedule of an engineer, except PMs and TLs have this meeting, and yeah. So in our team, people that I work with, they only have 1 meeting, and it's planning meeting, and it's not 1 hour, it's 20 minutes. 1 meeting a week, and it's 20-minute meeting. It's pretty awesome. This is pretty much the worst case. So you are not really disturbed during the day if you can work most of your day. You don't have many meetings to deal with. So the most important meeting is the planning meeting, the iteration meeting. This picture looks a lot better on my thing, but it's Google Stockholm. It takes 15 to 30 minutes. The goal is to make it as short as possible and as efficient as possible. And this is the core of my talks. Please pay attention. So what we do at these meetings, we look at the stuff in backlog, not in icebox. The PM already put stuff from icebox to backlog, and it's already sorted in priority. We look at the backlog, and we don't look at everything in the backlog. We only look at the top of the backlog, because we work from top, and we only are planning for 1 week. we have 1 week iteration, so there's no reason to look down like 3 weeks from now. So we look at the first week, and we just make sure that if there is a list of user stories, that they are broken down into tasks. All we do is we make sure that they are tasks, not the stories, and we estimate them. Now the estimating, that might be slightly new to you, but it's actually useful. I'm going to explain why. So this is like 5th time I'm saying backlog is ordered by priority. This is really important. And you estimate only as you go. Only for the next week. Don't estimate more than 1 or 1.5 weeks. And the way you estimate it, you give it points, not days, because people are horrible at estimating hours or days. But if you ask someone, this is a 1-point task. You know how hard it was, right? Yeah. Is this one harder or easier than this 1-point task? Oh, it's twice as hard. Okay, it's going to be a 2-point task, right? So it's much easier to estimate in terms of how difficult the task is instead of how quickly you think in your ideal, naive world, how quickly you would get it done.
So what is the echelon of 1 point?
Every team has it differently. You start by, at the very first iteration meeting, first time ever, this is one-time thing, you would put a small task on the whiteboard and a larger task on the whiteboard, and you would say, hey everyone, this is 1 point. Remember, this task is about 1 point, this is about 3 points. And then you start estimating, and you calibrate, you end up synchronizing with your coworkers. It ends up being really interesting. I'm going to go into it in the next slide. So we have these cards. They call it the planning poker. Everyone has these. It's question mark, which means I have no idea how many points. 5. Infinite, it means like, oh, this needs to be broken down into multiple tasks. This is way too big. 1, so it's like modified Fibonacci sequence. 1, 2, 3, 5, and way too many. And what happens, there's one facilitator, a person who, usually a tech lead. In my team, we rotate. So everyone is the facilitator about once a week or once a month. So the facilitator says, the facilitator just reads the task. And then we just say 1, 2, 3. And at the same time, everyone lists their card. There's no discussion, nothing. You just vote immediately after the task is read. We look, and if everyone says 3, 3, 3, 3, 3, 2, or 2, 2, 3, 3, 3, 3, 3, or something like that, where you know the majority, you just pick the majority and you move on. You don't even discuss the task. But if you have 5 and 1, then you know that the problem is that people don't understand what the task is about. So the real reason why we estimate is not because we want to know how many points things take, which obviously the PM likes it because the PM knows that, oh, we do 20 points a week, so the PM can tell how quickly we move. They call it velocity. That's good for PMs. For us, estimating is purely used to define the requirements, to clearly state what the task is about. So we would have this, and then the person with the highest number would say, to do this task, I have to do A, B, and C. No more discussion. Then the person with the lowest number would say, to do this task, I have to copy existing code and make a 1-line change in it, or something. And then we revote. And all of a sudden, we mostly match. And we continue doing this until we match, until we reach majority, and we move on. So this meeting, in a week you might have like 10 tasks, and we disagree on like 3 of them. This meeting is like 15-minute meeting. It's a really short meeting. It's really efficient. So that's the estimating. And then once the meeting is over, we go to our desks. We pick the top task. It doesn't matter whether we know anything about it. We always pick the top task. And then if someone else knows more about it, we sit with them, ask them, pair with them. It's important that you pick stuff, any task that's there, so that you actually learn about new stuff. You need to go outside of your comfort zone. Don't pick the task that you've done before. Pick something new. And I already talked about transparency. It's always clear who's working on what. And this is optional, and I strongly discourage you to do this, but since I'm talking about Agile, I need to mention this. Some teams do this. They actually stand up, and they stand for 10 or 15 minutes, 6 people standing for 15 minutes equals
1.5 hours.
wasted. 1.5 hour wasted. Why? Look at the whiteboard if you want to see what people are working on. Why do you need to stand up and talk about who's working on what? But for some teams it works. Again, everyone defines their own rules. Who am I to judge? It works for them. They can do this. They stand up, they say what they've done yesterday, what they're going to do today, and what they're being blocked on. And this, I believe, is the last slide. Yeah, we're almost done. Retrospectives. These are very important because this is what defines your team. If you start doing it one way, in a month you will have a meeting and you say, is this really working? Should we have these 15-minute stand-ups every day? Like, I wake up at 10 o'clock. I'm not going to be at work at 10. Right? I don't want to go to stand-ups. So people discuss what they think it works, what didn't really go well, if they had any kind of emergencies or something, the planning didn't go well, and what we can do better. And you walk out with a list of action items. Suggestions. Anyone on the team can suggest. This is really collaborative effort. It's not like a manager doesn't go to this. Manager doesn't go to any of these meetings I was talking about. It's always just the tech lead and the developers. 4 or 5 people, sometimes 6. This is very useful. You look back, you improve your process. We used to have 1-hour meetings, 1-hour planning meetings every week. Thanks to retrospectives, we were able to optimize them down to 15 minutes a week. Thank you. We have still plenty of shirts to give out, so whoever asks a question will get a shirt or a sticker, whatever they want. You want an answer? Okay.
Who does the breakdown from user stories to tasks?
From user stories to tasks? Usually a tech lead, because the tech lead would know most about what is the most efficient way to implement something. But if you have a team that has multiple senior engineers or people who are really interested in designing and architecting the systems, then, okay, the question was, who breaks the stories into tasks? So, yeah, in our team, we have 3 senior engineers, so we all do that. But sometimes, you know, if you know what the tasks are, people just keep adding tasks to our software whiteboard. They are already broken down. Sometimes during the meetings, we realize that the task is too big, and we break it down right there in the meeting when we're planning it, when we're estimating it. What would you like? Just come here and get what you want. It's going to be efficient. Just take everything except for my laptop. And my chopstick. And there's pens and pins. Next question? Go ahead.
You were talking about creating unit tests for your software.
Yeah.
To developing software for smaller clients, it's very expensive to make it much bigger because of unit testing. Do you have some advice how to solve this problem without creating unit tests for software?
So I'm not talking about end-to-end tests. I'm not talking about automation tests. I'm talking about little unit tests. It's all Java. It doesn't require any kind of setup. So it's not really, it doesn't really make the work much longer. And it's slightly longer, but then you avoid bugs, which you then later you would have to go back and fix. And we have very strong testing culture. Unit tests are important. If you don't write tests, the person who reviews your code won't approve it. They will say, write your test and then come back to me.
But do you have a hard rule for which task is worked on? Like, if there is a single P1 task left, and there are a couple of P2 tasks, but I know that this P1 task would be more suitable for someone who is working on something else right now, but is more familiar with that area of the code.
Yeah, sometimes happens. So the question was, if there is a specific task which we think it's more suitable for a specific engineer that knows most about it and will take her or him much faster if we actually ask that person to do it. We shouldn't, but we actually do sometimes. Don't tell anyone. Ideally, you would just, anyone who is done with their previous task will pick the next task. But sometimes it happens when we have a person who is expert on JavaScript, on some JavaScript refactorings. He's going to do that. We have a guy who's crazy about visualizations. He's going to be happy to pick up the next visualization task, right?
Can you tell me what was the
Come get something.
most challenging thing you have done in Google?
Most challenging thing at Google?
Yeah, you have done already.
You mean work-wise?
Yeah.
So I can't really tell you about specific stuff I work on. I cannot even tell you what features I worked on. It's one of the policies.
Okay,
So I cannot really tell you, but I think the things that are most challenging are when I'm dealing like, okay, I can tell you something, which is not very specific, but in general. Last quarter I was trying to figure out how to, it sounds silly, how to stream data 3 times faster than a regular Java library would let me do that. So I had to go kind of down closer to the middle to figure out how to avoid the slowness that the libraries introduce. And then you have to spend a lot of time profiling it, and that was challenging and tedious, and it wasn't fun. You can get something from the table. And there's business cards too if you guys want. So there's stickers, pins, pens, and t-shirts.
You said that you attend the meetings with PMs, and then you know the user stories and stuff like that. I suppose engineers always know why they do their work.
Yes, so I probably need to step back here. We do have a company-wide goals. They call them objectives and key results. And there's a company-wide meeting that you can either show up or you can watch it on your computer, where we know next quarter we are going to really focus on that product or mobile or something. So, and then each team then has their own goals, their own set of objectives and key results that directly try to achieve the company-wide objectives. And then it keeps breaking down, and every single person has their own goals. It's required that every developer creates their own list of objectives for the quarter, and every quarter you have a different set of objectives. So you should be, if you are a developer, you should know what's the big picture and what your role in the big picture is.
Okay, and second question is about...
Oh, you want two things, huh?
Yeah, unit testing. So I suppose you write your unit tests and everything, so when you have QA, do they write also tests? Or that's only
QA?
for if you have the software engineer
Yeah,
for
so there's
testing?
actually multiple types of people that actually test. Software engineers write unit tests. If they don't have an SCT or TE, if you remember that slide, on their team, they actually have to write end-to-end tests as well, or automation tests. The QA are people who do manual testing. In the browser, following steps, opening, just making sure the UI looks good, nothing broke.
Okay, and who writes test cases?
Who writes test
PMs?
cases? TEs, test engineers. But if the team does not have test engineers, then software engineers have to do that. Come and get your stuff.
Okay, yeah.
What's the time, by the way?
7:10.
What's the time?
7:10.
7:10? Oh, we're doing good. I thought it was much more. Okay, there's a lot of stuff here, so maybe you should get 2 things when you come, when you get a question. I'm sorry, he was asking first.
How good are you at your estimates, actually? I understand that you said you are not basing your estimates on a time basis, but anyway.
What was the question here?
How good are you at your estimates?
How
I mean, if you
accurate are the
assigning
estimates?
the points to the task.
So the estimates are good enough where when you take an average of 3 weeks, you know what your velocity is. And so you know roughly what's your weekly velocity, and it allows PMs to decide, or you can tell the PM, this won't happen this quarter, because our team can only do 20 points a week. And you are asking me to do something that's 60 points. So it's important, but it's only important to the PM. It's not important to engineers. For engineers, it's just the exercise, the ritual of estimating that allows you to understand what needs to be done. Because if someone gives you a task and you start working on it and then you realize that no one really agreed what it's supposed to be doing, then you just waste a lot of time.
So let's say this task like makes some streaming 3 times. This task makes some streaming 3 times faster. You never know if you even accomplish this.
Yes.
And
right.
you can hardly break it down into smaller tasks. So
And yeah, so
how
there's
you
a lot of
estimate-
tasks
so how you
that
estimate
you don't know how long they're gonna take. And so you would just create a 1 point or 2 point task to do a spike. which means spend no more than 4 hours and figure out if there's an easy way to do it. And in 4 hours, you learn whether you need to go and change some library, or whether you can reuse another library, or whether 7 people tried it already and no one could figure out how to do it. It's going to be a lot harder. You're gonna know after you do Spike whether this task is even doable.
And Spike is, for example, some
Spike
Google
is like
search in the web.
yeah,
some
Google search.
forums.
We usually search for our own code. We have code repository and we just look at example. And very often I search in our code search, and I see this. Oh, this is cool way. This is the good way to do it. And I scroll up and author Petra Cross. Go and have a long lunch. Yeah, it's just regular like anywhere else.
And do you measure how much point get each member of your team?
So you can actually, if you are rigorous and you write down who did what task, and you can put that and then add it all up, you can see the individual velocity, how quickly individual people can deliver. And you can see that senior engineers usually have higher velocity than more junior people. But it's fine, it should be going up.
Okay, and do you use it for planning for work?
No, because the points are interchangeable. The goal is that we don't want to define points based on who is going to do it. We don't want to assign tasks ahead of time. We know it's a 2-point task, and it ends up averaging anyways per team. So if it takes me 3 points and it takes her 2 points, it's okay. It's going to average out. Because next time I do something that I can do faster.
Okay.
Go ahead, get some stuff.
Okay. Do you work with wireframe when you start a new project?
No, we don't do that. And we don't use UML and all those things that they teach at schools.
But mock-ups.
I mean, yeah, when there is a major system redesign or design, like Gmail backhand, those are a number, it's really complicated. Obviously, you go to a whiteboard and you start drawing boxes and link them. But I think wireframes are mostly used by UI designer to see what's the user experience from page to page. I'm sure they use them. But software engineers who develop systems, they just create a box for this server, an API for that server, and it just ends up becoming like I don't know, it looks weird. Come and get stuff.
But you use some mockups for user interface.
Yeah, but again, this is something, I'm not the right person to answer this question because I'm not a UI designer. I did see mockups around. People use Photoshop or Fireworks to mock up UI changes, but I haven't been doing that myself.
If for some reason the developer isn't able to finish the task, does he put it back on the backlog?
Oh, yeah.
Or
So
is there a special meeting?
the question was if the iteration is over and there's still pending tasks or tasks that were never picked up. Well, if you never pick up the task, it's still in the backlog, it's okay, because you're going to pick it up in the next iteration. If you already started working on it, it's okay, you just finish it in the next iteration. And the points will count for the next iteration. It all averages out.
If I'm totally unable to do it?
If you're unable to do the task, then you would say, hey, I'm going on vacation, pick it up, or continue.
No,
I actually done this. A part of this is called hose and go, when when something breaks and then you go on vacation. That's the worst thing, no one should be doing that. But before I left, I was working on something and it had to be done by a certain deadline. And I had to leave, I had to go on the airplane. So I just asked my coworker to take over. And he just did.
And
Come and get your stuff,
I
guys.
think he meant like if you estimate like it's 3 points and then it ends up like infinity.
So what happens, yes, there have been situations like that. The question is, you estimate a small number of points and it ends up growing. What we do, we just add another task for it. And we just rename the first task to say spike. Do a spike, figure out how long it's going to take. And then that was like a 1 point. And then if you know how to do it and you know it's going to take a lot longer, then you're going to create multiple additional tasks for it. And then you start working on them in the next iterations. Get more swag.
How long is Spike?
Spike?
Typically.
Typically, couple of hours, from couple of hours until a couple of days.
So it's not like you should never do Spike longer than a day.
Well, I understand, like, there might be, I mean, Spike is, you can use it anyway. I'm sure that there might be people who use this word to describe something that they spent 3 weeks on. When I say Spike, I mean couple of hours to a couple of days.
Was there such a situation that someone is being assigned a task and then he finds out that task is above his abilities, he cannot do it, so he returned the task and said, okay, it's too hard for me.
Well, that's why we have, it's like a family. If you don't know how to do it, you're gonna ask your mom or your dad to help you with it, right? So we just walk to whoever knows the most about it and just say, give me a hint, give me a pointer, where should I start looking, what am I missing? If you are not going outside of your comfort zone, you're gonna never learn. So this pushes you.
What did you mean by saying that someone is in trouble when Gmail runs down for 2 hours?
Well, actually, people are not really in trouble. But what we do post-mortems. It sounds morbid, but post-mortem it's like a CSI research. What happened? Why did we end up in this situation? And it's important not because we want to blame someone, but because we want to make sure that we avoid this happening in the future. If something goes wrong with my system and there are users that are affected, manager might say, send me a post-mortem by tomorrow. And then post-mortems usually would have a timeline. It would go like 4 a.m., 50,000 users cannot access Gmail. 4:03, pagers are going off. 4:04, SREs are looking at it, site reliability managers. And then 4:30, system is back up. And then there's like, you create a timeline of what happened so that anyone can read it and learn from it and say, ooh, that means that we need to make this system more robust, or we need to, I don't know, improve something. It's very useful to do postmortems. But people don't point fingers like that, because no one wants to screw up.
He's fired, right?
No.
So there is nobody investigating if like your code broke the production?
Oh, so my code will break a continuous build. And someone tells me, hey, I broke the build, or I'll notice it.
You have a bug
And then
which
once it's
doesn't-
pushed to production, there will be a bug. If there is a bug in production, then if it's a small bug and it only affects like 0.5% of users, then it might be a lower priority bug. If it's a high priority bug, we have people who are on call to actually constantly be looking at user reports and filing high priority bugs and even fixing them themselves, or finding whoever created the feature to roll it back or fix it. So there are people on call who do this. But it always goes back to the person who wrote it, and this person knows most about it and can quickly fix it.
So nobody's blaming people.
There's no. Sometimes it's funny. We just
Even if
laugh,
it's
like,
review?
you again. One more time, and you're gonna bring in chocolate cake or something, you know? It's like, it's fine. There's no fear.
Have you ever think of working for another company?
If I ever thought of working at another company,
Yeah.
I actually did work at another company before Google.
Okay. For example, now Mark calls you. And
Oh, I keep
offers you
getting calls from recruiters.
Yeah.
But no, I haven't been thinking about it yet. I mean, obviously, I'm not going to be at Google until I die. There's a chance I'll work somewhere else at some point. But I don't have a reasons to go now.
And do you have some more formal specification of the task than these little poke stickers? Like
Formal specifications of the tasks. No. Everything that we know about the task is on the... It's not the sticker. It can be a post-it note, but it's the white one, so it fits. It should be one sentence, no more than one sentence. And it's okay. It needs to be small. Because if you start writing something long, it means, oh, this is a big task. You need to break it down into smaller ones. Just keep it simple.
Do you convert bugs into tasks, or do you just
If we convert bugs
consider
into
it a single
tasks,
task?
yes, and some teams make red cards for them instead of yellow. You can mark them in different colors so that you know that you need to work on them first, or know that they are chores instead of real features.
Do you have dedicated build engineers who take care of your machines and
So
continuous integration?
There's two structures besides the engineering. They kind of belong into the engineering. One is site reliability engineers, and these people have pagers, and they're mostly very good at system administration. They know how to bring the machines back up. They come sometimes and tell you that you broke something. They're always on call. And then there's a release engineering team, and these people are taking certain version of the code, building binaries, pushing them to staging, waiting until testers and QA are done. Then they keep pushing it and rolling it to production. They work closely with SREs, and SREs watch graphs, making sure that the new code doesn't bring things
I meant
down.
like your continuous integration, like
Continuous build?
environment and stuff. Or
Software
do it on
engineers
your own?
manage their own continuous builds. I mean, it's a one-time setup. Every now and then it needs to be modified. But we build cop them. We have a rotation. Every single engineer, at least once a month, has to spend the whole day watching those green and red builds and keeping them green.
What do you use for continuous?
We have around almost everything.
Hmm?
How much time do we
Yeah,
have?
one more.
Because I would need to leave very soon.
Questions.
Last two questions?
Yeah.
Okay.
Yeah, you said that you use red cards for the bugs, so I expect you have a less number of bugs, let's say less than 50.
Yeah.
What if you have
Oh, you would.
200 bugs?
Well, you fix bugs as soon as you know about them.
Okay, but if
It's not like you have a whole list of bugs and they are like in the backlog forever. No.
so you never had something like 200 bugs?
No. No. Some people use word bugs for feature requests, and sometimes.
No, just bugs.
Okay, just bugs. No. Every team has a small number of bugs. Okay, one more question, last question, make it good. Last impression, anyone?
How would you describe with 2 or 3 words the culture?
This is like the most lengthy question you could ask. How can I describe the culture? I don't know. There's so many. There's no way to describe it in few words. The culture is very much like in dorms, like at the university. It's very informal. People are very friendly. There's lots of friendships, and even people hook up. Like I found my husband at Google, but it's very, very friendly, very warm. It's competitive, but people like to help one another. We do stuff together even after work, but obviously not with everyone, but you find friends. When you go to parties, when I go to parties, 60% of people at the parties are Googlers. We create their own social circle in a way. Yeah, it's a great culture. It's a good culture. All right. Thank you so much. So now we are on a first come first serve basis. If you can get here fast enough, you can get whatever you want. And there's some business cards for you.